Don't touch your picture monitor. We're using these color bars to test for signal quality. Now, we are having some technical difficulties, but we'll have them corrected in just a few seconds with the help of a waveform monitor. Ah, there we go. Just a moment. We have to make one more adjustment. That's better. Now, what you've just seen are a couple of the problems we often deal with during production. They're just two examples of why it's important to know how to check the technical elements of a production. Of all the creative effort and hard work that go into our shows, the technical quality is as vital as the script, the talent, or the director. Now let's get down to work. This size will make it easier for me to keep things into perspective for you. The key to maintaining quality and consistency in a production is to carefully monitor the picture signal before it is recorded or transmitted. One of the most important instruments you need to maintain a television signal is the waveform monitor. It lets you see if a picture signal is impaired. With it, you can correct problems, and we'll show you how using the Tektronix 1710B waveform monitor. Before explaining the displays and tests, I'll quickly review the graticule and how it relates to the picture. The graticule is divided into two dimensions. The vertical IRE markings measure amplitude. You'll use those for level setting. And the horizontal markings measure timing. Remember, a picture is made up of 525 lines. Each of the horizontal lines is scanned from left to right. Part of the picture signal, called the sync pulse, sends the beam back to start another line. Here's how this looks on a waveform monitor. The horizontal graticule line is the time scale. That tells you where the picture beam is at any instant in time. And the active video is here, above the 0 line. And this is the horizontal blanking interval. That includes the sync pulse and the color burst. Now remember, the sync pulse prompts the picture beam to return back to the left side for the next line of scanning. And what we see on the display is a composite of all of the scan lines of the picture as they're received. The waveform monitor actually shows these lines in pairs. Now that's so we can see the complete horizontal blanking process in between. Now, let's go into the control room and set up the waveform monitor just as if we're starting our production from the beginning. Because the monitors are operated under different conditions, there are a few controls you should know about to adjust the illumination and focus on the CRT. The brightness of the display can be changed using the intensity knob. And the focus knob adjusts the focus of the trace. The graticule brightness can be adjusted with the scale knob. Next, we'll position the trace so we can make the measurements. To do this, we'll use the test signal color bars from the system generator. With the position controls, we'll set the blanking at 0. If the equipment is operating properly, the sync tip will be close to -40. The black level will be at 7.5 IRE, and the color burst will fall between 20 and -20. Now that we're set up, the next thing we should check is synchronization or timing. There are two timing measurements we should make, horizontal phase and burst phase. Maybe you can better understand timing by comparing it with a musician. A soloist can play at any tempo. No coordination with anyone is needed, but if other instruments are added, a conductor is necessary, and the same is true in television. The timing information on a picture monitor is here, off to the side of the image we see. On a waveform monitor, it's here, and it's called the horizontal blanking interval. Whenever you combine one source of video with another, both must be timed together or the picture will jump during switching. Watch this. Notice what the horizontal blanking interval looks like on the 1710B waveform monitor when this happens. To eliminate the problem, we'll lock our waveform monitor to a reference signal, which is usually black burst. It's connected to the waveform monitor's external reference input. All of our picture sources are routed from the switcher to channel A input on the waveform monitor, so our picture sources will be displayed when we switch between them. Make sure they're properly terminated. Now we'll choose one of the picture sources as our prime signal. In this case, we'll use color bars from the sync generator. Next, we'll set the waveform monitor to external reference and display our prime signal on channel A. While we're making a timing measurement, you may also want to magnify the signal to get a closer look. This allows us to see just the timing information or the horizontal sync pulse. Using the vertical position control, move the sync pulse of the prime signal so that the 0 line intersects halfway down the leading edge of sync. Using the horizontal control, move the sync pulse leading edge to a major division mark at the far left on the 0 line. Remember where that point is, because you'll compare the signal you're trying to time with this prime signal. Now we'll time our second picture source to our prime signal. To display our second picture source, just select it on the switcher. We can see the sync pulse of the second source is in a different position, indicating it's not timed with the prime signal. The picture jumps when we switch from one signal to the other. Remember, our waveform monitor only shows us what's happening. To correct problems, we'll use the controls at the picture source. So adjust the timing using the horizontal phase control of the second source. That's located either on the camera or the time-based corrector. With these controls, move the sync pulse to the same division mark where the prime signal was. Now the picture sources are timed. We've horizontally phased our sources together. To get back to our original display, turn off the magnification and readjust the display with the position controls, returning the blanking to 0. Before we go to our next timing measurement, burst phase, we'll quickly show you something you should check periodically. The horizontal and vertical blanking intervals should fall within recommended limits, and here's what you should look for. The waveform monitor display should be magnified. The horizontal blanking interval can be positioned on the screen using the horizontal position knob. To check the interval, we'll measure its width. The start of the horizontal blanking is where the active video ends, here. The interval ends where the next line of video starts, here. Each division represents 1 microsecond. If the width is correct, the horizontal blanking interval will end between 10.7 and 11.1 microseconds. To check the vertical blanking interval, leave the display magnified and set the sweep to 2 field. Use the horizontal position knob to place the interval on screen. The vertical blanking interval should begin here. It ends where the next line of video starts. The first part of the interval contains vertical serrations and equalizing pulses that take up the first 9 lines. So we'll begin counting here at line 10. The complete vertical blanking interval should have a maximum width of 21 lines. After you've checked these, be sure to return the display back to the 2H sweep mode. And you'll also want to turn off the magnification and then reposition the display with the horizontal and vertical position controls. Getting back to our other timing measurement, we should check burst phase. Again, we'll use our prime signal on channel A to match the color burst of the other signal. Make sure the prime signal is displayed before you begin the measurement. By turning on the burst phase indicator and pressing reference set, 2 green lights indicate the proper operation is set. When we select the second picture source on the switcher, you may see the color shift and a red light come on. As we adjust the burst phase of our picture source, again, that's on the camera or time-based corrector, the yellow lights appear, followed by the green. Since you've matched both the timing and burst phase of the 2 sources, you won't see timing or color shifts when you're switching between sources. Repeat this process for each picture source you use, each time comparing the picture to the prime signal. Once our picture sources are timed, the video levels must be set. The waveform monitor has two modes we can use while setting levels. We've been using it in the flat position, which shows all the picture information, color and luminance. By switching to the low-pass filter, only the luminance or brightness in the picture is shown. This low-pass mode is sometimes easier to use when setting video levels from a camera. The 1710B has a special dual display feature that allows both the flat position and the low-pass filter to be seen simultaneously. To do this, press and hold the filter button until the image is displayed in flat and low pass. This will let you make a better comparison. To return the display, press and hold the filter button back to the flat position. With this video, we'll use the vertical markings on the graticule. We already said the black level should be at 7.5 IRE. The brightest part of the picture should not exceed the 100 IRE mark. If the picture is too hot or bright, the display will look like this. And if the picture is dark, the waveform will look like this. Moving through this picture, see if you can make the correlation on the waveform monitor. In fact, the waveform monitor is to a television director what a light meter is to a photographer. With it, we can make sure we have the correct amount of light on each scene. Setting the levels is easy. You simply adjust the levels with the controls at your video source until the levels fall within the 100 IRE and the 7.5 IRE range. The color bar test signal provides a quick reference to check the operation of your television system. Let's look at the color bars on the waveform monitor to recap what we've just learned. This is what they look like in the low-pass mode. Be sure the blanking is at 0 IRE. The tip of the sync pulse should be about -40. The white flag, here, should just hit 100 IRE. Finally, check to be sure the black level is at 7.5 IRE. Again, adjustments can be made with the controls at your video source. Color bars should be recorded prior to each shoot to be used as a reference later during editing. By this procedure, you'll be able to correctly set video levels. A waveform monitor is a good source of reference for checking levels throughout your production. The measurements are that simple. Our picture sources are now adjusted. You've seen how important technical quality is to the overall effectiveness of your production. Also, how important and easy it is to use a waveform monitor to help you set timing, adjust the burst phase of every picture source, and monitor and adjust picture video level. No one can guarantee that using test equipment will make your programs more effective, but they'll be ineffective if the picture jumps around, the colors shift, and the levels bounce up and down. Help your audience concentrate on your message, not your technical problems.